In class, we developed a linear optimization model for the transportation problem. We defined our decision variables as xij to represent the number of units to ship from origin I to destination j, where we had 3 origins, Shanghai, Guangzhou, and Taipei, and 4 destinations, Long Beach, Reno, Tacoma, and Denver. We then defined our objective function to minimize the total transportation costs, followed by our capacity constraints for Shanghai, Guangzhou, and Taipei. Then we defined our demand constraints for Long Beach, Reno, Tacoma, and Denver. And finally, we defined the non-negativity constraints for each of these 12 decision variables. In this video, we'll review the steps to set up this problem in Excel to be able to use the Excel solver to solve this optimization problem. The first thing we have is the transportation costs that were given in the problem from each origin to each destination. That's already on the spreadsheet in cells B3 to E5. Next, what we'll do is we'll set up the decision variables and constraints all together. First, what I'll do is I'm going to copy the headers for each destination, and then I'm going to copy the text for each origin as well. We now have these cells, these 12 cells. We will specify these as our decision variables. So I'm going to highlight them in yellow so we remember that those are the decision variables. Next, what we'll do is we'll set up the capacity constraints. Now, every constraint has a left-hand side, an inequality or an equality, and then the right-hand side. In this case, the left-hand side represents the number of PVs that are shipped in the solution. And the right-hand side represents the number of PVs that are available. Since we can't exceed the number of PVs that we have available, all these constraints are less than or equal to constraints. So we're just going to remind ourselves that they're less than or equal to. Now, under TVs available, let's specify what we have for Shanghai, Guangzhou, and Taipei. And then for the left-hand side, what we need to do is we need to figure out an Excel formula to represent x11 plus x12 plus x13 plus x14. Well, this happens to be in cell B8, C8, D8, and E8 along the row. So all we need to do is sum the row. We can use Excel's sum formula for this. And then we can copy this formula down, since the next two capacity constraints will be the similar thing. We want relative references, so as we copy it down, it will correctly move to row 9 for Guangzhou and row 10 for Taipei. Now we've specified these the information we are going to need for the capacity constraints. Now what we'll do is we're going to specify what we need for the demand constraints. So here we're going to have TVs received for the left-hand side. And TVs required for the right-hand side. These are all going to be greater than or equal to constraints. And the number of TVs required in Long Beach is 6,000. In Reno is 4,000. That's our demand. And then we have 2,000 demand in Tacoma and 1,500 demand in Denver. Now, to get the left-hand side, the number of TVs received in our solution, we need to have an Excel formula to represent x11 plus x21 plus x31. This is conveniently located in our spreadsheet in the B column from cell B8 to B10. So we can also use the sum formula for this. Note that there's no coefficients on those left-hand side. So that's why we're just going to sum without having to use the transportation cost. We'll use the transportation costs later when we define the objective function. So now we have the first constraint for Long Beach. All we need to do is copy that formula across because there are similar formulas for Reno, Tacoma, and Denver. Okay, the next thing we'll do is we'll set up the objective. Our objective is to minimize the total cost. And we're going to set up an Excel formula for this objective function. I'm going to set it in red. Now this could be done through specifying equals cell B3 for the transportation cost from Shanghai to Long Beach times the decision value x11, and the same thing for x12 for 2 times x12, and so on. That can be a little tedious, so it happens to be convenient that the Excel has this Excel formula called the sum product formula. So we're going to make use of that here. It does exactly what we're trying to do. So we'll go ahead and select all of the transportation costs, all of the coefficients that we're going to have, and then we put a comma, and then we select all of the decision variables which we're going to be multiplied by, and then they're going to all be added together. And that's what the sum product formula does. Now I hit enter. Now I've specified everything that I need in the spreadsheet. Now what I'm going to do is go into Excel Solver and reference the cells that I've set up here. The first thing is to set the objective cell. So in this case, that cell is in B16. I'm going to go and select it, the red one. Next, I'm going to decide if it's a max or a min problem. In this case, it's a minimizing total cost, so I need to make sure I select this min. By changing variable cells represent the decision variable, so I want to select all of the yellow cells. Now I can start to set up the constraints. I'll click Add. I can set up more than one constraint at a time as long as they have the same sign. So all of these less than or equal to constraints, the capacity constraints, we can do them together. I'll select all of the left-hand side, 3 of them. Then I'll keep less than or equal to, and I'll select all of the right-hand side. There'll be 3 of them, and that will set up 3 constraints in Solver. Okay. And there we go. There we have 3 constraints. Now next is to create the demand constraints. So I'll click Add. I'll select all 4 left-hand sides. And I have to remember to change the sign to greater than or equal to. And then the right-hand side. Those are in row 13. I'll select those 4. And then now I've included all of the capacity and demand constraints. The only thing missing is the non-negativity constraints, but it's okay to use this make unconstrained variables non-negative. And since this is a linear program, we can go and use the simplex method to solve it. So let's click solve this model. It says solver found a solution. All constraints and optimality conditions are satisfied. That's fantastic. Let's click OK. And let's see, what is this solution? Well, let's report the solution in a text box. I'm going to create a text box. I'm going to give it a different color shading. And let's type out our optimal solution. It is to ship 3,500 units from Shanghai to Long Beach. We're also going to ship 1,500 units from Shanghai to Reno. We're also going to ship 2,500 units from Guangzhou to Tacoma. Rather, that is Reno. And the 2,000 units are the ones that are going to be shipped from Guangzhou to Tacoma. We're also going to have 1,500 units, which we're going to ship from Guangzhou to Denver. And finally, we're going to also ship 2,500 units from Taipei to Long Beach. This optimal solution yields a minimum cost of $39,500.